This video runs through the answers to Test A, Section B, the multiple choice questions. In question 9, you're asked about group 2 hydroxides. You have to identify the statement that is not correct. Magnesium hydroxide is milk of magnesia, so that one is true. It is used for treating indigestion. Right? The anion in strontium hydroxide is the OH minus ion. Okay, there's 8 electrons in oxygen, 1 in hydrogen, and an extra electron. So there are 10 electrons, that's true. And barium hydroxide is the product of the reaction between barium and water. Barium reacts with 2 waters to give you barium hydroxide and hydrogen. So that's true. The incorrect statement is statement B. Calcium hydroxide is an alkali, so you wouldn't use it to neutralise an alkaline soil. You'd need an acidic compound. So the correct answer is B. Question 10 asks you about oxidizing agents. An oxidizing agent accepts electrons. Fluoride and iodide are already reduced, so you can rule those out straight away. They can't accept electrons. You then need to consider which is the best oxidizing agent from fluorine and iodine. Fluorine accepts electrons more readily because it has fewer shells, less shielding, so the nucleus has a greater attraction for electrons, so it accepts the electrons more readily. So the correct answer is A. You have to heat water in question 11 to change it from liquids to gas. That means an endothermic energy change is occurring, so it can't be A. When you change the state of water from a liquid to a gas, you are not breaking the molecule down. It's not thermal decomposition, so you are not breaking covalent bonds, so it's not B. In D, when you heat water, you're increasing the thermal energy of the molecules. They move around more and the bonds vibrate more. So the total energy of the molecules increases, not decreases. The correct answer is C. When you vaporize water, you overcome the intermolecular forces, which in the case of water are hydrogen bonds. Water has an unexpectedly high boiling point because the hydrogen bonds are very strong. Question 12 asks about chemical tests. There are 2 tests here. There's a test involving aqueous silver nitrate, which is a test for a halide, and it produces a white precipitate when you have a chloride ion. Adding a sulfate to an unknown compound gives a white precipitate if barium ions are present, because barium sulfate is very, very insoluble. Looking down the list, the correct answer is A. The barium chloride is soluble. It will give you soluble barium ions which will react with the sulfates to give a white precipitate, and it gives you chloride ions which react with the silver to make silver chloride, which is insoluble and white. The ammonium sulfate does not give a precipitate with either chemicals. The potassium chloride only gives a precipitate with the silver nitrate, and the strontium nitrate will not give a precipitate with the strontium nitrate will give a precipitate with the sulfate but not with the chloride. Question 13 is tricky. This is asking about the major and minor products formed in electrophilic addition with asymmetric alkenes and an asymmetric electrophile. The way I tackled this question is by drawing the product. The molecule in blue is 2-bromo-3-methyl-butane. As you can see, the main carbon chain is branched in this molecule. This means that it must have been formed from a branched alkene. That means that you can rule out molecule B immediately. Molecule B is a straight chain alkene, so can't form the desired product. Electrophilic addition reactions proceed via a carbocation intermediate. So in order to work out which is the correct answer, we need to decide which carbocation is formed from A, C and D when you add hydrogen bromide. The carbocation formed is going to be the one that has more alkyl groups attached to the carbon with a positive charge. I've highlighted in yellow the carbon that ends up positively charged after the first step of the electrophilic addition, in which a hydrogen is added to one side of the double bond. Both A and C will give you the carbocation on the left, a tertiary carbocation with 3 alkyl groups attached to the carbon with a positive charge. This carbocation will lead to 2-bromo-2-methyl-butane, which is not the correct product. D, on the other hand, gives you a secondary carbocation with 2 alkyl groups attached to the carbon with a positive charge. I've drawn this at the bottom. This, when it reacts with the bromide ion, gives you the desired product, 2-bromo-3-methyl-butane.